recording. Good morning again, grade 8. We are now in the second quarter, module 1, weeks 1 to 4, right? Again, as what I had promised, we will start the actual second quarter today, okay? We had just finished the first quarter, module 2, weeks 5 to 8 last week, right? And upon checking, a lot of you didn't actually submit, okay? Those offline students. Please remind your classmates, please inform them that I already received all the modules of the offline learners. It's in here, okay? From module 1 to module 2, and a lot of them didn't actually submit. Well, it's up to them. We cannot force them to do so. Well, definitely, I cannot give them grade. As simple as that. Same as when you were still in grade 7, okay? Same strategy, same as is. Now, whatever you actually gain will be reflected on your grade slips or in your records, right? Let's move now to faults and earthquakes. Okay, what's with the faults? How can we connect faults with earthquakes? And how these actually affect us in our daily lives? A fault is a fracture or zone of fractures between two blocks of rocks. Faults allow blocks to move in relative to each direction, okay, to each other's direction. This movement may occur rapidly in the form of earthquake, okay, or occur slowly in the form of creep. Okay? Faults may range in length from a few millimeters to thousands of kilometers. Okay, most faults produce a repeated displacement over geologic time. Okay, during an earthquake, the rock on one side of the fault suddenly slips with respect to other. So tendency is, if there are some slippage happening, there is also earthquake because these plates move in relative direction, right? The fault surface can be horizontal or vertical or some arbitrary angle in between or mixed movements. Let's take a look at later what are these movements and how can we identify these movements. Okay, the two sides of a non-vertical fault are known as the hanging wall and foot wall. Okay, the hanging wall occurs above the fault, okay, or fault plane, and the foot wall occurs below the fault or below it. This terminology comes from the mining. Okay, when working in a tabular ore body, the miner stood with the foot wall under his feet and with the hanging wall above him. Okay, just like this one. So you are now looking at, again, the hanging wall and the foot wall. Okay, usually the hanging wall is smaller than the foot wall. That is really common. Okay, types of faults. Let's move now to the types of faults. What are these types of faults? Okay, first is the strike slip fault. Okay, strike and slip. Okay, there are two terminologies there. We have strike and slip. It involves the right as well as the left motion movement of Earth's crust. Okay, in a strike slip fault, the motion or movement occurs on near vertical plane. Okay, when plates on the other side of the fault moves horizontally with respect to each other. Okay, just like this one. Okay, this is the left lateral strike slip fault, this one, and this is the right lateral strike slip fault. They are actually moving opposite to each other. They are actually sliding to each other. Okay, that is actually strike slip fault. Let's move now to dip slip fault. Okay, there again two terminologies there. We have dip and slip. Okay, when you say dip slip fault, this may occur either on the vertical or horizontal. If strike slip fault is moving towards left and right, okay, dip slip fault is moving vertical or horizontal motion on movement of Earth's crust. Deep slip fault is further classified into normal fault. We have two classification. Okay, again, in strike slip fault, we have right lateral strike slip fault and left lateral strike slip fault. So we have two categories or types. In the deep slip fault, we have also two. Okay, we have classified into normal fault and reverse fault. What's with the normal fault and reverse fault? The deep slip fault is developed at an angle to Earth's surface and relative movement of motion is up and down. Okay, if it is up and down, this is deep slip fault. Okay, this is the normal fault. Take a look at. This is the hanging wall and this is the foot wall. Okay, normal slip fault is the hanging wall is towards what? It is actually moving upward. Okay, if the hanging wall is moving upward, therefore it is a normal fault. But if the hanging wall is moving downwards and the foot wall is moving upwards, this is a reverse fault. Okay, normal fault. When the upper rock or hanging wall tries to move down, okay, it is known as normal fault. Okay, hanging wall. When the crust is extended, the normal fault occurs. It is also called as the extensional fault. The downward block between two normal faults dipping towards each other is called the graben. Let's take a look at graben later. Okay. And the upward block between two normal faults dipping away from each other is called the horst. Okay. If you're going to look at this one, okay, this is your foot wall, okay, and this is your hanging wall. Again, if the movement or when the upper rock or the hanging wall tries to move down, okay, just like this one, it is considered as the normal fault. Okay, but if the hanging wall moves up, okay, it is considered as the reverse fault. Okay, when the fault is an opposite to the normal fault, it is called the reverse fault. Just like this one, the hanging wall is moving up, so it is actually reverse fault. How about step fault? Okay, step fault system consisting of a number of faults in a parallel fault plane or fault plane. The separated blocks slipping in the same direction along parallel planes, giving a step-like feature. This fault is called the fault terrace. Okay, if you're going to look at it, it looks like this. Okay, it actually resembles a staircase. This is actually a step fault. Throw fault. Okay, this is a fault system in which two normal faults occurs whose fault planes are inclined, providing a common down throw side between them. Okay, the block between two fault plane forms a long trench called graben or a reef valley. Okay, let's take a look at graben and horst later. Some gravens are very long and also deep and may fill with water and become water stream. If you're going to look at it, okay, again, this is the horse, okay, and this is graben. So let's take a look at this illustration here. Okay, the upper part is called the horse. This one, okay, this one, horse, and the lower part is called graben. Okay, this is between two normal faults. Oblique slip faults. Do you have any questions so far with the discussed topic?
None.
Question before we continue? All right. Oblique slip fault has a component of a deep slip fault and strike slip fault. Sure, how can we visualize that one? This is actually a mix or mixture between deep slip fault and strike slip fault. Generally, all faults have component of both dip slip and cyclic fault. It is caused by a combination of shearing and tension of compressional forces. Okay, if you're going to observe, it has a relative left and right movement and up and down. So it is a mixture of dip slip fault and strike slip fault, right? Do you have any question with faulting? Question
No.
with faulting? Okay, let's have this question. Why do we have faults? What's in the fault? Do you have any idea? Why did fault occur? Why did fault occur? Idea? Grade 8? Do you have idea? Are you still with me? Okay.
Because of the tectonic plates.
Because of, again, come again?
Because of the tectonic plates.
Tectonic plates, correct. Because there is a relative movement of the tectonic plates. Correct. You got it right. Okay. The movements of these plates enables earthquake to occur and enables also to what? To have tensional forces underneath the crusts. This enables also to create what? Faults. This is the reason why we have a lot of faults, and this is also the reason why we have a lot of earthquakes. Right? An earthquake is what happens when two blocks of earth or crusts suddenly slip apart or slip past one another. The surface where the slip is called the fault or fault plane. Okay? The location below the earth's surface where the earthquake starts is called the hypocenter or focus. Okay? And the location directly above the surface is called the epicenter. Okay? I know that you heard already these terminologies, correct? Am I correct? Okay. So if you're going to look at this, the hypocenter or focus is in the lower side of or lower part of the epicenter. Above the hypocenter or focus is the epicenter. Okay? Sometimes an earthquake has a foreshocks. These are similar to earthquakes that happened in the same place as the larger earthquake that follows. Scientists can tell that an earthquake is a foreshock until the larger earthquake happens. Okay? Take note that scientists until now cannot actually predict earthquakes. But it can tell if there are some shaking on the ground. Okay? That is why we have to prepare. Like for example, in areas where the Pacific Belt Ring of Fire is located, okay, just like Japan, we are also located in the Pacific Belt Ring of Fire. Those places that is actually near the Pacific Belt Ring of Fire contains a lot of volcanoes and contains a lot of seismic activities. Meaning to say that these are prone to what? Prone to earthquakes and prone to volcanic eruptions. The largest main earthquake is called the main shock. Okay, main shock always have aftershocks that follow. Okay, these are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, Aftershocks can continue for weeks, months, and even years after the main shock. See? Remember that these waves, these earthquakes moves in a wave form. Meaning to say that it will actually go into the ground. It will what? It will travel in the ground. Okay. Earthquake focus on epicenter. Okay. I think we discussed a lot today as an introduction to our topic. We also done discussing faulting or faults. I think that will be for today, class. Do you have any questions so far? Questions so far before we go?
None.
Are you sure?
Yes.
All right. If you have question, please raise it in our GC. Or if you have something in your mind that you want to express, you can always share it in the class, all right? Do I make myself clear?
Yes.
Everybody, okay. Right. We had discussed a lot and hopefully you learned something out of our simple discussion. I think that will be all for today, class. Have a nice day, grade 8. Take your lunch. Bye-bye.
Bye, sir.